Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss HUYGEN'S principle. Let's begin. According to HUYGEN'S wave theory of light, each point source is a center of disturbance from which waves spread out in all directions. The locus of all the other particles vibrating in the same phase is called wavefront, as we discussed. So, according to HUYGEN'S principle of wave propagation is a geometrical method of finding the shape and position of a wavefront at some instant. The position and shape at some later also. So, according to HUYGEN'S principle, it states that every point on a given wavefront, that given wavefront we treat as the primary wavefront, which acts as a source of new disturbance. That primary wavefront nothing be the source of new disturbance, that creates new disturbance, which is called secondary wavelet. That new disturbance is produced is named as secondary wavelet. From primary wavefront, the new disturbance is produced and that new disturbance is named as the secondary wavelets. That secondary wavelets spread out in all directions in the medium with the velocity of light. The envelope of these wavelets, as the wavelets are formed, so the envelope of these wavelets in the forward directions, so the envelope in both backward directions and forward direction is produced. We consider the forward directions at any instant gives the new wavefront, and that new wavefront is the secondary wavefront. That new wavefront which is produced due to the forward directions of that wavelets at any instant is known as the secondary wavefront at that particular instant. The secondary wavefront at that particular instant. That is the HUYGEN'S principle. Now, we understand the HUYGEN'S principle considering the example of a spherical and a plane wavefront. Let A be represents the section of a primary spherical wavefront at any instant in a homogeneous isotropic medium due to a point source of light. This is a spherical wavefront. To find the position of the wavefront after an interval t, according to HUYGEN'S, each point on the primary wavefront AB is the center of secondary wavelets. This point. These secondary wavelets, there are a number of points, so each point treat as the center of secondary wavelets, and these secondary wavelets travel with the same velocity in that of medium, that is the velocity of light. Let we consider a number of points named as, let A, B, C, D, E, F like this. on that of primary wavefront AB. These points act as the source of secondary wavelets. In time t, each of these secondary wavelets will move through a distance ct. Distance will be velocity into time, as the velocity of that propagation of wavefront is nothing which is equal to the velocity of light. So, the distance travel by each of these wavelets is c into t. Now, they travel with a distance c t, again that also travel with a distance c t. Now, we draw the spheres taking c t as radius. Here also same thing, we draw the sphere taking as ct as radius. These are the spheres. Imagine it in case of 3D. And these spheres are called the secondary wavelets that are originating from the points on primary wavefront AB. Now, we draw the envelope of these secondary wavelets. Let me draw the envelope of the secondary wavelets. Named as A1, B1, here also A2, B2. A1, B1 is termed as the forward secondary wavefront. A1, B1 is named as the forward secondary wavefront. A2, B2 is known as the backward secondary wavefront. The backward secondary wavefront. Here you see the HUYGEN'S statement. The envelope of these wavelets in the forward direction at any instant gives the new wavefront, that is the secondary wavefront at that instant. So, no mention of that backward secondary wavefront. What happened at that particular case according to HUYGEN'S? We should get not only forward wavefront A1, B1, but also the backward wavefront A2, B2. But Huygens further postulated that the action of that secondary wavefront, or we can say the action of the secondary wavelets, these are the wavelets, the action of secondary wavelets was confined to the points at which they touched the forward path of their envelope. Thus, we considered that only the forward wavefront, and we assumed no such backward secondary wavefront existed. However, there is does not exist any physical or mathematical justification for these assumptions, as there will be no such existence of backward secondary wavefront. Now, we neglect that unwanted part of that of secondary wavefront. We only consider the forward part of that of secondary wavefront. This is the example of shape and position of wavefront at some instant by using Huygens principle in case of spherical wavefront. That is a spherical wavefront. That one is a spherical wavefront. Spherical wavefront. Same thing taken into considerations for plane wavefront, we can draw the shape and position of plane wavefront at some instant. Here A, B is the plane wavefront. These are the wavelets, some points at that of plane wavefront, which creates the secondary wavelets A, B, C, D, E. There are so many points. Now, that wavefront travels with the velocity of c. So, after time t, we have get the sphere having radius ct. Same thing. Join the envelope. It is A1, B1, which is the forward secondary wavefront. Similarly, the backward secondary wavefront A2, B2 is formed, but according to Huygens principle, we just consider the forward wavefront, not the backward secondary wavefront. That for plane wavefront. Look here, the direction in which the disturbance is propagated is called ray, or we can say ray of light. the direction in which the disturbance is propagated. That the direction in which the disturbance is propagated. So, the ray of that be the ray of light as we drawn in case of spherical wavefront. Let that be the source. These are the conditions for spherical wavefront. These are the rays, and that rays denote the direction which the disturbance is propagated. And in case of homogeneous isotropic medium, the rays are always normal to the wavefront as shown by that arrows. If we consider again a plane wavefront, in case of plane wavefront or any wavefront, any safe wavefront, these arrows gives the direction of propagation of light. In case of homogeneous isotropic medium, these rays are always perpendicular to that of wavefront. That wavefront may be spherical, may be cylindrical, or may be plane. Okay. Here Huygens have no such physical or mathematical explanation to the point why there will be no such existence of backward secondary wavefront, or why we do not consider backward secondary wavefront. Further, two scientists come into picture. The scientists named as Huygens and Kirchhoff they provide the mathematical way to prove why no existence of secondary backward wavefront. According to their mathematical concept, the contribution of a wavefront, the contribution of a wavefront the contribution of a wavelet, the part of that wavefront, that is the wavelet, in any direction, that making an angle theta which is normal to that of wavelet. The contribution of a wavelet in any direction which is making an angle theta with the normal to that wavelet is directly proportional to half of 1 plus cos theta. That mathematical formula was proposed by Huygens and Kirchhoff. So, according to this mathematical formula, for the portion of the wavelet which just lies on the back of secondary wave, in that of case theta is equal to 180 degree. So, we write here for the portion of the wavelet which is just lies on the back of secondary wavelet theta is equal to 180 degree. Therefore, now we put that value here, 1 half 1 plus cos 180 degree, cos 180 degree is equal to minus 1, half 1 minus 1, the result will be 0. Therefore, the forward secondary wavefront A1 B1 is the new position of the wavefront after time t. No such backward secondary wavefront. Therefore, which indicates the forward secondary wavefront which is A1 B1 is the new position of wavefront after time t. The backward wavefront is neglected. This is the mathematical reason why we consider the forward secondary wavefront. That mathematical explanation was proposed by the scientists Weygott and HUYGEN's. So, with the help of this video lecture, we understand what is Huygens principle, the statements of Huygens principle. By using the Huygens principle, we take the position and propagation of wavefront at a particular time instant. This for spherical wavefront, that for plane wavefront. What is ray? And a mathematical way to explain why backward secondary wavefront is not exist. So, with this useful and informative notes, let me wind up this session. Thank you.